We want to find the partial sum, S sub 20, for the following series. 16 plus 14.7 plus 13.4 plus 12.1, and on. So first we need to begin by analyzing the pattern. How do we go from one term to the next in this series? And it looks like we are actually subtracting the same number each time. In other words, we'd be adding a negative number. And if that's the case, then this means this is an arithmetic series because we have a common difference. So just a reminder, if the pattern is not obvious to you and you want to test to see if you have a common difference, then you would say your common difference would be the difference between the first two terms. So take the second term, 14.7, minus your first term, 16, and you'd get a value of negative 1.3. And then you want to see if this is indeed the value that you would add to go from one term to the next. So looking at your next two consecutive terms, the third term, which is 13.4, minus the previous term, 14.7, and you see that that's also a difference of negative 1.3. And you could test it out one more time, looking at the fourth term, which is 12.1, minus the previous term, 13.4, and that difference is indeed negative 1.3. So this is just verifying that indeed we do have an arithmetic sequence. We are subtracting 1.3 each time, which means that we have a common difference of negative 1.3. Now we want to find the sum. This is called a partial sum because we're not adding up all the terms of the sequence, since it appears that this sequence goes on forever, but rather we want to just add the first 20 terms together. So we're looking for S sub 20. And we're in luck because we have a formula for the partial sum of an arithmetic sequence. So S sub n for an arithmetic sequence will be n, the number of terms, times a sub 1, the first term, plus a sub n, all divided by 2. In this case, if we're looking for S sub 20, then we'll be adding 20 terms, n equals 20, times the first term, which is 16, plus the 20th term. And we don't know the 20th term, so I'll just leave that right now as a sub 20, all divided by 2. So we can't go any further with this computation because we don't know a sub 20. We do not know what the 20th term is of this series. So one way to find the 20th term would just to be continuing subtracting negative 1.3 each time, or rather, let me say that differently. You could continue to subtract 1.3 each time, which is the same as adding negative 1.3, and do that 20 times. But that's not very efficient. It would be more efficient to go ahead and utilize some of our prior knowledge. Since we've studied arithmetic sequences, we know that you can find any term that you want utilizing the following formula. A sub n is equal to the first term, a sub 1, plus n minus 1 times d. So in this case, we're looking for a sub 20, where the first term is 16, plus 20 minus 1 times d, and d is negative 1.3. This gives us the 20th term is negative 8.7. Now we can go back to our partial sum, and we can fill in this piece that we didn't have before. Now we know that the 20th term is negative 8.7. So 20 times the quantity, 16 plus negative 8.7, all divided by 2, and we get a grand total of 73. So 73 is the value of the partial sum for the first 20 terms.